Good evening. Today we're gonna do Toon Lighting, right? And maybe some inking methods, right? So Toon Lighting really is just about taking the original like light formulas, right? The BRDF or whatever, right? And then just like quantizing it so that we can fit it within this slice of you know of values that we can just control, So we can have something that looks like cartoons or anime or generally any medium that doesn't like doesn't use realistic lighting, doesn't use the formulas that are presented by our real life estimations from physics or whatever, right? And the basic you know idea is that we're gonna take whatever black and white formula we get from the lighting and run it through a quantization stage, a quantization filter, whether it was through a color ramp or curves, or I don't know, if you want it to be two-tone, just use a step function, right? And we're just gonna take that back and multiply it by our color source. And usually the lighting comes from two sources, right? The most common ones, which are either directional lights or point lights. Now, we don't want to delve too much into this, right? If we're right at the beginning. If you want a simple way to just get some Toon Lighting without any headaches that works with your editor, right? You don't want to mess around with the nodes too much. All you have to do is just go into the shading tab, right? And give it a second, of course. Go into the shading tab, right? And, I'm going to use a diffuse BSDF because it's much simpler, right? And then you're just going to run it through curves instead of running it through color ramps, which is what a lot of these naive methods do. There's a YouTuber that used this RGB curves function. I'm going to put his name up or something. But yeah, you just take this shader to RGB in Eevee, right? And just gonna plug this in. Of course, it is the same, right? Nothing changed right now. But what we're gonna do is we're gonna take this lighting. Blender is crashing a bit. Ain't that fucking stupid? We're gonna just go to the color management and change it to standard for a second here, because that is like the color space I like to work in when I'm doing stylized stuff. And we're just gonna, stair step it, really. I'm gonna take this and, I don't know, maybe make it like this, and yeah, basically try to form a stair step pattern. That is like how you get it to look so stylized, is by making sure the domain is like pretty much straight. Right? If I were to say, I don't know, lower this one last step, that wouldn't do much harm, really. Yeah. That should pretty much do it. Yeah, and you can just kind of stair step it as much as you'd like, and it just preserves the color, it preserves the ambience, it preserves everything. And if you're to say, I don't know, use the principal BSDF, sorry. What is that? It would still do the same. All it does is it takes it, takes in the lighting formula, and it just uses a little stair step pattern to remap it. And yeah, like gets you like 80 or 70% of the way there, which is like a good percentage. That's almost like everything, really, if you're doing just a basic shader. The thing is, the advantage of this, or any toon shading thing, right, is that this is the thing that I don't think a lot of people discuss, that you can still apply a lot of the principles to it. If you want to preserve details of normal maps, you still have the right to, really, right? You can just, take your normal map. Of course, in this case, I'm just going to use a bump map because I don't have a normal map picture on me right now. And, you can just plug it in, and it affects how the light reacts. So if you want to put something like scales or chains, or you want to have a little cobble pattern, you can pretty much do that. You're not gonna fight the engine a lot on that. Okay, I don't know what's going on here. Yeah, that should do it. Yeah, you can see, like, it still preserves that Toon Lighting while I can still get as much detail as I'd like, Of course, excuse the noisiness a bit. I don't know what's up with Blender. It used to work fine without all that noise, but they had to smear all that TAA bullshit over it, but whatever, right? So, yeah, that is like pretty much the principle of it, is that the source of the normals doesn't have to be the original geometry. You can do the same thing as you do in PBR, which is just like a normal map or a bump map or whatever. And the same thing goes for the rest of like the properties, roughness and metalness and everything. It works really well. I think even like if you were to put ray tracing on it, it should work well, I think. Yeah. Whatever, right? So basically, yeah, that's how you do it simply, right? Now, there's my method. And my method is a very annoying one, where you just actually start building up the lighting in the goddamn fragment shader. And you do that by taking in your normal, right? We're going to do directional light first, right? You're going to take in your normal, and you're going to take this little special node here that you can get the dot product between whatever direction you specify here, the normal, and you basically just get something called Lambert diffuse lighting, right? This is really cool, but the problem with it is that you can't really control the terminator, which is this gradient, right? It kind of is in a little tiny area between the start of the light side and the end of it. What we want to do is have a little more control, And if we want to have a little more control, we're going to change its range. Right now its range is between -1 and 1, which is the reason we only start to see the difference in the light side, which is 0 to 1, which is in the middle. So we're going to want to change the range of that to, we're going to add 1 and then divide by 2, or multiply by 0.5, it doesn't really matter. I think multiplying by 0.5 is more performant, but this makes it much simpler to read, right? And this gives you like a proper gradient of what the darkest area that doesn't face the light should look like, and the lightest area that does face the light, right? So that gives us like a true gradient where we can control where the terminator starts, right? So if we were to like, compare, I don't know, like let's make this little band here of light values, right? Like you can see, we have control until like the end of what the dark side should be, right? With regular Lambert, right, you barely have any control. So that's the reason I use a wrapped version or a warped version of Lambert. I don't know what Valve called it really, but yeah, that gives you like a lot of freedom. That would just be diffuse lighting. Of course, after that, you basically can multiply it by the color you want it to be. RGB, and there, right? Here, you can control the sun here. And we can take all of this really and just, put it into a little node here. And yeah, that is like, it should be like our sun node. What else, right? This is directional light. if you want to get a point light, right, well, what you're going to do is that we're going to get a light source at like this imaginary position, right? And we're going to take this imaginary position, we're going to normalize it, right? You can go to vector math, normalize. That gives you a direction, right? A pure direction without any link to it, so that it doesn't fuck up the dot product formula, right? And we're just going to take this and find the dot product as we did in the one before, but that one is much more convenient for direction, right? So we're going to take the normal and we're going to get the dot product between it and the light source. And now if you just move it, you can just kind of get a feel for where the light is, really, right? Like the direction between it and every fragment, right? Now the thing is with point lights is that the thing that differentiates between them and directional lights is the fact that they get weaker, you know, as they get further. The inverse square law, I think it was called, right? And what you're going to do is that we're going to take this pure line, but we're not going to wrap it because that gave me issues earlier. And we're going to take our position, and we're going to find the distance between the two, right? So, basic Pythagoras theorem, right? You're going to take this position, you're going to take this unnormalized, you know, it's not the direction, we want the actual position, right? And it shows us this white result. And the reason it shows us this white result is because, you know, the distance between the fragment and the light can be as big as it wants to be, you know? It can be 0, which means it's not really, you know, that far away. The pixel is like exactly where the light is, or it can be like 1 billion because the light is very far away. So how do we use that to kind of control, you know, the lighting? Well, all we have to do really is that we're going to take this, and then we're just going to divide it. Really, that's all there is to it. Where's divide? Yeah, there you go. We'll take our thing here, divide it, kaboom. You know? It's done. Let's put a couple other objects to put this really into perspective. You know? We put a cube. I don't know. Something. You can see this controls how far on the X it goes. This controls how far on the Y. This controls how far on the Z, right? So this is like really at the middle. This is like it's much lower. This is like much higher, like as if it was like a sun ball or something. I don't know, right? Yeah, that like pretty much it does most of the work for you in making a point light. You can start like I don't know, like if you were to take a value here and you were to divide by it, right? The bigger it is, the bigger the radius of the light, and the smaller it is, the smaller the radius of the light. Right? That's very simple, right? And in the end, like you can take it, multiply it again, like a 1D multiplication. Math multiply. What? Math multiply. Yeah. Not by the distance, but by something else. I don't know. Call it intensity. Right. Again, take this. You can remap it again. Right. Okay, so let's improve this little node here by just multiply. And you can just kind of go here and just change this to become a color and put it right here. Yeah. this is a where did it go? A vector. This is a color. We can rename it, call it color, right? And this is the normal. Yeah, and then you can like kind of control the lighting inside it, but whatever, right? We're gonna pretty much do the same thing for this. We're just gonna take it. Plus, I'll take this color amp, constant. Do the same thing to it. All right, and take all of this, Control G, put it in a group, and we're gonna put some inputs here. So the first vector is the normal. Second would be the position. Third would be the light position, right? I don't know what's up with the double O's. And we're gonna take this, gonna put it right here, call it radius, light radius. It's a float, right? It's a 1D value. And by default, it's, I don't know, 3, right? Yeah, anyway. And what else? Yeah, the intensity. Of course, the last thing, X color, multiply, light color. The light color here, I don't know, make it blue or something, right? And if you were to want to like take both these lights and just basically add them together, it's as simple as adding them together. So we're gonna take this, change it to add, just take this other vector, add them, kaboom, you are done. You have Toon Lighting here, you know. It's the greatest thing ever, I guess. I don't know, maybe make this a little more sun neutral color or something. And yeah, you have to add it to its fullest because that's how like a regular add operation should work. Yeah, you kind of have a bit more control over that. And yeah, you can just like keep adding more lights. And this gives you a lot of control, but it's pretty much a headache in trying to visualize where everything is. You can use geometry nodes maybe to control that, but that's really beyond the scope of what I wanted to show today. And again, you don't really have to use the normal. You can just use something like a bump map or a normal map if you'd like to have a little variation. So I'll use the noise texture this time to avoid the weirdness from before. And I'll take this and turn it into, you know, put in the height. Put it at 0.3 or something, right? And use it as the normal here, use it as the normal here. Make sure you input the same values for every light, unless you're doing something we already did. So you can get this really great result here. You know, we can still preserve the detail and still look, you know, more like a Toon thing. So yeah, that's like how I handle two kinds of approaches on lighting. One obviously stolen from another creator. Thank you for your time.